Hello friends, welcome to our channel Engineering and Technology for You. In today's video, you will learn about the Wi-Fi 6 technology. Now you all are aware that Wi-Fi is a popular wireless networking technology. Wi-Fi stands for wireless fidelity. Wi-Fi 6 is the next big thing in Wi-Fi. It finally brings Wi-Fi standard to the network that supports everything we want to do with wireless LANs. Expectation to connect everyone, everywhere, and everything is rising. So Wi-Fi 6 would be the solution for that. So let us start with the introduction. Wi-Fi is said to get better and faster with its upcoming major update. 802.11ax, also known as high efficiency wireless, will be commonly referred to as Wi-Fi 6. This is a new naming standard set by Wi-Fi Alliance, with previous generations now being known as Wi-Fi 5, that is 802.11ac, and Wi-Fi 4 802.11n. Wi-Fi 6 is the next generation wireless standard that's faster than 802.11ac or Wi-Fi 5. More than speed, it will provide better performance in the congested areas from stadium to your own device packed home. It's coming in 2019. While plenty of routers are already available with chips using draft specification, 802.11ax or Wi-Fi 6 won't be finalized until December 2019. Wi-Fi Alliance visuals for device manufacturers. These are the Wi-Fi Alliance visuals. This is for Wi-Fi 4, Wi-Fi 5 and Wi-Fi 6. Then let us see what Wi-Fi 6 is expected to accomplish. More overall bandwidth per user, ultra high definition and virtual reality streaming. Then support for more simultaneous streams of data with increased throughput. Then more total spectrum, so 2.4 GHz and 5 GHz, and eventually bands in 1 GHz and 6 GHz. That is what is expected. Then the said spectrum split into more channels to enable more routes for communication. Then improved performance as much as 4 times at maximum range of an access point. Then better performance, robustness in outdoor and multipath, that is clutter environments. Then ability to offload wireless traffic from cellular networks where reception is poor. So these are some of the expectations to be accomplished by Wi-Fi 6. Now let us see the core technologies that Wi-Fi 6 will change to the present standard Wi-Fi 5. First is YAMU, that is multi-user, multiple input, multiple output. So this is the multiple user, multiple input and multiple output. We'll discuss in details. Then second is OFDM, orthogonal frequency division multiple access. Then next is 1024 quadrature amplitude modulation, QAM. Then longer OFDM symbols, then dynamic fragmentation, then special frequency reuse or BSS coloring, then beam forming, then target wait time TWT, then uplink resource scheduler, then trigger based random access, then 2 NAV network allocation vector, then improved outdoor operation. So these are some of the core technologies which Wi-Fi 6 will change when it is out. The first is YAMU, that is multi-user, multiple input, multiple output. So Wi-Fi 5 Wave 2 introduced multi-user YAMU, but only supports 4 simultaneous connection on downstream, 1 on upstream. While Wi-Fi 6 will be able to handle 8 streams of data in either uplink or downlink, supporting more users at once and offering 4 times the maximum theoretical throughput of Wi-Fi 5. Then YAMU access points also handle more signal processing than single user, that is single user YAMU APs, uploading that burden from endpoint devices. Then multi-user YAMU traffic is considered to be secure until tools are developed for processing the signals, as only the internet recipient can read the data. So these are some of the advantages of using the multi-user, multiple input, multiple output that will be used in Wi-Fi 6. Then next is the OFDM, orthogonal frequency division multiple access. So presently it is not part of Wi-Fi 5. There is a regular OFDM in Wi-Fi 5. Then this technology is borrowed from 4G LTE networks, allows for resource unit allocation in a given bandwidth, incorporated on Wi-Fi 6. So more clients, that is as many as 30, can share the same channel instead of waiting, while also improving efficiency by combining different traffic types. Then OFDM is compared as a multi-user version of OFDM. So this will definitely improve the efficiency in Wi-Fi 6. Then next is the diagram for this. As you can see here, this is the OFDM and this is OFDM-A. So as you can see here, this is the frequency and this is the time, and number of users here 1, 2, 3, they are shown here. But here, as you can see, the multiple, say the users have increased a lot. So that is how the OFDM-A will improve the performance. Then next is 1024 quadrature amplitude modulation QAM. This is the increase from 256 QAM on Wi-Fi 5. Though some routers from this generation have 1024 QAM as an experimental feature, but then it is not used. So this boosts throughput by cramming more data into each packet. Then 1024 QAM uses 10 bits per OFDM symbols versus 8 bits used for 256 QAM. A 25% capacity boost that results in theoretical single stream data rate of 600 MB per second using 80 MHz channel, and 39 better than theoretical 433 MB per second single stream data on Wi-Fi 5. Let us see the diagram so that it will be clear. So here you can see this is 256 QAM and this is 1024 QAM. So here 8 bits per symbol are used. That is the 802.11 AC. It uses 256 QAM, whereas 802.11 AX, that uses 1024 QAM, 10 bits per symbol. So as we are using 10 bits, more data can be carried by this type of modulation. Then let us see the next technology. That is longer OFDM symbols. Longer OFDM symbols increases the duration that an OFDM symbol is transmitted from 3.2 milliseconds on Wi-Fi 5 to 12.8 milliseconds on Wi-Fi 6 and supports a longer cyclic prefix for each symbol. So cyclic prefix CP adds a portion of the end of OFDM symbol to the front of the payload to provide a guard interval against inter-symbol interference and to improve robustness, since this portion can be used if necessary. So that is to avoid the inter-symbol interference, this is used. So this figure can be adjusted depending on overhead requirements. A longer CP repeats more data and occupies more space in symbol, resulting in lower data rate. But then the interference will be reduced. So this is another technology used by Wi-Fi 6. The next is dynamic fragmentation and beamforming. So dynamic fragmentation, here let us understand this. Wi-Fi 5 has a static fragmentation which requires all fragments of data packet to be of the same size except for the last fragment. So dynamic fragmentation allows these pieces to be of varying size for better use of network resources. So the different fragments can be of varying size. So that will make use of the network resources efficiently. The next is beamforming. So it exists in Wi-Fi 5, though that standard supports 4 antennas and Wi-Fi 6 increases this to 8. So beamforming with 8 antennas is done in Wi-Fi 6. Beamforming improves data rates and extends range by directing signals towards specific lines instead of in every direction at once. This aids MIMO, that is multi-user, multiple input, multiple output, which doesn't work well with rapidly moving devices. So beamforming was optionally available on Wi-Fi 4 devices, but became necessary with the implementation of MIMO on Wi-Fi 5 Wave 2. So again it is continued in Wi-Fi 6. So the next is spatial frequency reuse or BSS coloring. If multiple access points are operating on the same channels, they can transmit data with a unique color identifier that allows them to communicate over the wireless medium at the same time without waiting, as long as the color enables them to differentiate between each other's data. Now here you can see network without BSS coloring. So here you can see this all blue color, this will be congested, so there will be interference between these. Whereas in network with BSS coloring, only this and this will interfere with each other, others will not interfere. So that is how we can do the spatial frequency reuse. Then next is target wake time, TWT. Now TWT, target wake time, scheduling instead of contention based access. So here a router can tell a client when to sleep and when to wake, which is expected to make a considerable difference in battery life, since a device will know when to listen on a channel. So as you can see in the figure, see here user 1. Now this is the negotiation when to wake up, reduce contention between users. So user 2 is not awake here, he will awake here. User 1 will be awake here, and other time he will be in the sleep. So target wake time, so that is the scheduling. So this will have up to 67% lower power consumption. So that is what is target wake time, which will be used in Wi-Fi 6. Then next, Then other features, let us see the other features. First is uplink resource scheduler. Similarly, instead of users computing to upload data as on today's wireless networks, Wi-Fi 6 schedules uplink to minimize conflicts, resulting in better resource management. So uplinking of the data will be done by the resource scheduler. Then next is trigger based random access. Also reduces data collisions conflicts by specifying the length of an uplink window among other attributes that improve resource allocation and boost efficiency. Then two NAVs, that is the network allocation vectors. When a wireless station is transmitting, it advertises the duration it will take to complete, so that other stations can set their NAV, that is network allocation vector, to avoid conflicts when accessing the wireless medium. Wi-Fi 6 introduces two NAVs, one for the network that the station belongs to and one for neighboring networks. This should also reduce energy consumption by minimizing the need for carrier sensing. Then the next is improved outdoor operation. Several of these features will result in better outdoor performance, including a new packet format, longer guard intervals, and modes of improved redundancy and error recovery. So these are some of the other features of Wi-Fi 6. Then Wi-Fi Certified. So Wi-Fi Certified 6 is a trademark, an upcoming certification program from Wi-Fi Alliance that will ensure that devices based on Wi-Fi 6 or IEEE 802.11ax technology meet agreed standards and deliver key benefits such as higher data rates, greater network capacity, better power efficiency, and performance in remote or congested environments. So Wi-Fi Certified 6 brings next generation Wi-Fi to any environment that Wi-Fi Certified 6 devices will deliver capabilities required to ensure that users' next generation connectivity needs are reliable, met in a wide variety of scenarios. So that is what is proposed by the Wi-Fi Alliance. So maybe this certification program, it is upcoming, and as the vendors will design their devices, they will have to go through this certification program. So that is to ensure the key benefits of Wi-Fi 6. Then let us come to the conclusion. So meant to replace both 802.11n, it is Wi-Fi 4, and 802.11 AC Wi-Fi 5 as the next wireless LAN standard. 802.11ax or Wi-Fi 6 is being developed to deliver considerable increase in network efficiency and capacity for dense population centers with moderate improvements to peak data rates, which will be sustained better across more devices at once. Then because Wi-Fi 6 will have immediate impact on the performance of networks in crowded places such as stadiums or apartment buildings, the standard is expected to adopt faster than previous Wi-Fi iterations and will be eventually be necessary for home users as 100 Mbps per second to 1 Gbps per second broadband connections become more available, and as the rollout IoT leads to everything being online. So Internet of Things leads to everything being online, and for that Wi-Fi 6 will be necessary. Then contemplating Wi-Fi 6 more broadly, the boost in multi-user support and particularly the increase in simultaneous upstream connection will arrive alongside an accelerating demand for user data, which will be gathered from IoT, Internet of Things devices, and used for purposes such as machine learning, fueling artificial intelligence, the future of technology as a whole, and a growing digital economy. So Wi-Fi 6 will serve the future technology, that is artificial intelligence with machine learning, and of course the devices from the Internet of Things that will gather the data. So this is what is the conclusion. So with this we come to the end of this video. If you like the video, please press the like button, share with your friends, and subscribe to our channel Engineering and Technology for You. And if you want to get new uploaded videos from our channel, press the bell icon. So to get more videos on latest technologies and microcontroller and microprocessor, please subscribe our channel. Thank you. Then if you have any questions, you can always connect to me on Facebook, Gokhale Ulhaskumar, then on Twitter, @ugokhale, and by mail ulhaskumargokhale@gmail.com, and on Instagram, Gokhale Ulhaskumar. Thanks for watching.
I have you now.